What's up, everybody? This is Danny Mathematics again. Today I want to go over example 1 of how to find the area of a composite figure. Okay? Now, a composite figure is just a figure composed of simple shapes such as trapezoids, triangles, circles, squares, rectangles, etc. It's just a figure where you could put 2 or more simple shapes together, they become a composite figure. Okay? So what we want to do is, guys, we want to analyze this composite figure, and we want to figure out what simple shapes do we see within the composite figure, okay? And how I'm going to do that, guys, is I'm going to use my expo markers, and I'm going to color in the different shapes that I see from this composite figure, okay? So the first shape that I see, guys, is a triangle on top. So what I'm going to do is, guys, I'm going to highlight it blue. I see a triangle on top, so I'm going to highlight it blue, and I'm just going to put blue stripes in it just to make it stand out from the rest of the composite figure. All right, so once again, I see that I have a triangle and I highlighted it blue, okay? Underneath the triangle, guys, I see that I have a trapezoid. I have a trapezoid, okay? So what we want to do is, guys, we want to highlight the trapezoid its own color. So I'm going to highlight it green. I was trying to find another color, but I'm just going to use green. I'm going to highlight it green, and I'm just going to put some green stripes in it just so it can stand out from the triangle on top. All right, so once again, guys, after I identified each shape, what I did was I used my colored markers, or even if you're at home, you can use colored pencils. You can shade in each part of the composite figure, right? That represents a simple shape, and that will help you identify the simple shapes within the composite figure. And within this composite figure, guys, we have a triangle and we have a trapezoid. So we have 2 shapes that we have divided this composite figure into. So because of that, guys, we're going to draw a 2-column chart, because we have identified 2 shapes within the composite figure. If it was 3 shapes, you will have 4 columns. If it was 4 shapes, you will have, if it was 3 shapes, you will have 3 columns. If it was 4 shapes, you will have 4 columns, and so forth and so on, right? So the first column, guys, we're going to label that as our triangle column. And the second column, we're going to label that as our trapezoid column, okay? So once again, the first column is our triangle column. Okay, and then the second column, guys, we're going to label that as our trapezoid column. Okay, so we have the triangle and then we have the trapezoid. Now, next, what we want to do is, guys, we want to identify the area formula to each particular simple shape. Okay, so I need to find the area formula of a triangle, and we need to identify the area formula of a trapezoid. Now, of course, I have my formula chart because I'm in my classroom, but if you're at home, if you don't have access to a formula chart, all you need to do is go on Google or go on your internet search and just type in area formula of a triangle or area formula of a trapezoid, and it will appear on your search, okay? On your Google search or Yahoo or wherever you use, it will appear, all right? So I know for a fact, guys, that the area formula of a triangle is, I'm trying to see if I have another color that I can use. Okay, I do. Oh, no, I don't. Okay. Is the base of the triangle, which is the horizontal side of the triangle, right? Times the height of the triangle, how tall the triangle is. All divided by 2, and the reason why we're divided by 2 is because a triangle is technically half of a rectangle. All right, if you put 2 triangles that are the same size, together, it will form a rectangle or a parallelogram or a square, okay? Now, let's identify the aerial form of a trapezoid. Once again, if you don't know it, all you need to do is go on Google, type in aerial form of a trapezoid, and it will appear. All right, so the aerial form of a trapezoid, guys, is this. Base 1, which is the top base, plus base 2, which is the bottom base, right? Parentheses closed, because they have to be in the parentheses. So it's parentheses, base 1 plus base 2, parentheses closed, times the height of the trapezoid, right? All divided by 2, okay? So we have identified the area formulas for each simple shape that makes up this composite figure, okay? So the first thing, guys, that I want to do is, let's go ahead and let's solve for the triangle first. Let's solve for the triangle first. I think that would be smart. And I'm sorry, guys, I forgot one part. There's actually supposed to be a 15 right here as well, okay? I just forgot that part. This length right there is 15 as well. I just forgot to write that down, okay? So I have all my dimensions, okay? So let's go ahead and start. The base, which is the horizontal side of the triangle, is 15. And once again, I apologize for not putting that at the beginning of the problem. I thought I put everything, okay? And then the height, which is the vertical side of the triangle, right? Or how tall it is 10. So I have the base of 15 and I have a height of 10, and I need to multiply those together and divide by 2. So let's go ahead and do that and see what I get. So I have 15 times 10, which is 150, and 150 divided by 2 is 75. So the triangle in itself is 75 square meters. Okay, but remember, that's not our final answer. That is just the area to the triangle, okay? Now we have to figure out the area of the trapezoid, okay? Now I'm just gonna draw a little trapezoid over here, okay? Now I just wanna identify each part. Base 1 is the top base, base 2 is the bottom base, or they're interchangeable. You can say base 2 is the top, base 1 is the bottom, because base 1 plus base 2 equals base 2 plus base 1. So it really doesn't matter. But just know that the two bases are base 1 and base 2, okay? The height of the trapezoid will always be, or in most cases will be, this little dotted line that's vertical. That will represent the height of the trapezoid, okay? So let's actually look at the trapezoid. I see that the trapezoid actually has a height of 30 meters. So H equals 30. Okay, now let me look at my horizontal bases. Okay, base 1, I have 15 right here, but I have to add it to the 15 right here because this 15 only covers this part. So I have to add it to the other 15, which covers the other part of base 1. So 15 plus 15 plus 15 equals 30. So base 1 is 30. Base 2 is down here. Base 2 has a length of 35 meters. So base 2 is 35. So now, guys, all we have to do, guys, is just plug in these values where they go within the formula and solve. Okay, so once again, within the parentheses is base 1, which is 30, plus base 2, which is 35, parentheses closed, meaning that we're going to add these first before we do anything else, times the height of 30, right? The height of 30, all divided by 2. So now let's go ahead and solve. Remember, the parentheses, whatever in the parentheses, we have to solve that portion first. All right, so 30 plus 35, I assume, or I know, is 65. So now I have 65 times 30 divided by 2. So what I'm going to do is, guys, I'm going to plug that into my calculator, and I'm going to solve that. Okay? So 65 times 30 is 1,950. But remember, guys, I still have to divide by 2. So if I divide that by 2, I will get 975 square meters. 975 square meters. Okay? So we're down to the last part, guys. I got the area of the triangle, which is 75 square meters. Right? And then I also figured out the area of the trapezoid, which is 975 square meters. Now, in order for us to find the total area, we have to add those partial areas together. Okay, so now let's do that. 975, and I'm going to add 75 to it. Okay, 5 plus 5 is 10. I'm going to carry the 1. 7 plus 7 is 14. Plus that 1 I carried is 15. I'm going to carry the 1 again. 1 plus 9 is 10. So this composite figure has a total area of 1,050 square meters. This right here is our final answer. All right. So once again, guys, this is how we solve the area or figure out the area of composite figures. We break the composite figures into simple shapes. We find the area of each simple shape, and then we add all those partial areas together to get the total area of the composite figure. All right, so thank y'all so much for tuning in, and I will come out with more examples soon.